Dear students, very good evening. So in this video we are going to discuss about chi-square test. As we know that chi-square test is basically used to know the association between two categorical variables. We can also use chi-square test for testing the dependency or independency of two categorical variables. This means if you have two variables with chi-square test, we can say that whether those two variables are depending on each other or independent to each other. Got it? And the test statistic is calculated by summation of O minus C whole square by E, where O is nothing but observed frequencies which will be given in the question, whereas E is equal to expected frequencies. So expected frequencies will be calculated by a formula that I will explain in the example. So I have taken an example. So here 1000 families were selected at random in a city to test about the belief of the people whether high income families are sending their children to public schools or low income families are sending their children to the government schools. So all this data is arranged into a table which is shown here, and the question is test whether the income and type of schooling are independent to each other. So by using the testing of hypothesis, we have to test whether the two variables called school and income levels are independent or not. So our procedure starts with the null hypothesis. So as we know that null hypothesis is the first step. So here, while writing the null hypothesis, we have to take whatever question is asking for, that we will take as true in the null hypothesis. This means is asking us to test income and type of schooling are independent to each other. So we assume that the income and the schooling are independent. That's it. Now coming to the second step is alternate hypothesis. This is represented by H1. Now it's very simple. Alternate hypothesis is just opposite to null hypothesis. So here we need to take alternate as the income and the schooling are not independent. See, no need to write there as dependent. Whatever question is asking for to test, that we will assume in the null hypothesis, and opposite to that we will assume in the alternate hypothesis. We need to just take not independent. We should not take dependent. Now coming to step 3, level of significance. So he has not mentioned the level of significance, so we assume this as 5%. Now coming to step 4, test statistic. So in the test statistic, that is chi-square is equivalent to, I am writing the formula, summation of O minus C whole square by E. Okay, where O is nothing but the observed frequencies which are given in the question, like 370, 430, 130 and 70. Excluding totals, remaining all are observed frequencies. So here expected frequencies are calculated by E are calculated by row total into column total divided by grand total. Very simple. For example, if you want to find out expected frequency for 370, then its row total is 800 and its column total is 500 divided by grand total is 1000. So expected frequency of the first one 370 is equivalent to its row total is 800 into 500, 800 into 500 divided by 1000. Okay, similarly the second one expected frequency of 430. So expected frequency of 430 is equivalent to its row total is 800 into its column total is 500 divided by 1000. Okay, so it will give us. So likewise I have calculated expected frequency for 430, for 130 and 70. So I have obtained the expected frequencies of all the observations. Now we can go with chi-square calculations, chi-square table. Got it? So I will take all the data into a single table. So I have taken the structure O means observed frequencies, E means expected frequency. So we require this. So I have taken O minus C whole square and O minus whole square by E. So now if we take the first one, our O is 370 and its expected is 400. That means this is 370 and this is 400. And second one is, the second observed is 430 and its expected is 400. Similarly the third one is 130 and its expected is 100. And next is 70, its expected is 100. Now coming to the O minus C, so this minus this, so this is minus 30, so this is plus 30, this is plus 30, this is minus 30. Now coming to the squares, this is minus 30 square 900, this is 900, this is 900, this is 900. But we require O minus whole square by E. This means 900 divided by O minus whole square is 900 and its E is equivalent to 400. So 900 by 400. So this will give us. So likewise I have calculated for O minus whole square by E for all the observed frequencies. But we require summation of all this, so I have added 2.25, 2.25, 99. So I have got 22.5. So whatever value we have got, this is called as chi-square cal, that is equivalent to 22.5. Got it? Now here degrees of freedom is calculated by R minus 1 into C minus 1. So R minus 1 means number of rows. So here the number of, except totals, number of rows are nothing but low and high. So it's nothing but 2 only. So that is 2 minus 1 into columns also 2 minus 1. It will give us 1. So based on the degrees of freedom, our chi-square table value can be calculated at 1 degrees of freedom under alpha is equal to 5% is, so its table value is 3.841 for 1 degrees of freedom under 5% LYS. Now we can go with the conclusion. Now the conclusion is, let's check whether our chi-square cal, this is my calculated value and this is my table value. So my chi-square calculated value is more than 2 chi-square table value. So that means 22.5 is greater than to 3.841. So when our value is more, that means the null hypothesis bracket lo H naught is false, and it may be rejected. So null hypothesis may be rejected. If null hypothesis is rejected, then obviously our alternate hypothesis will be conclusion. What is our alternate hypothesis? The income and schooling are not independent. Hence the income and schooling are not independent. So this is the answer for this question. Thank you.